Now we ended in the part wherein we are going to get from the steam tables at the operating pressure of our column the saturated enthalpy of the vapor. So I just approximated this value so as I will not anymore interpolate. But in your case, again, as I have said, if there's a need to interpolate, you have to interpolate. And then we plug in this particular value in here in our formula that accounts for the enthalpy of the vapor. So accounting for its saturated vapor enthalpy and the superheat. Now I already edited the CP, the actual CP, which is 1.884. Your 1.8 is also okay, but if you can write 1.884, then your answer would be more accurate. Now you will have the HV here of your superheated vapor. So you need to get the sum of those two terms there. So this will be giving you a value of 2664.71, okay, kilojoule per kilogram. So we go back to that slide wherein we have the values. Check if we know them already. So this is we only have one more thing left to determine. So we have everything here except for the lambda S, the saturated, the latent heat of vaporization rather of the steam, and it has to be based on the information of the steam. So in the case, in our problem, our steam is at 172.4 kPa. So for steam at a pressure of 172.4 kPa, let me check if it's correct. 172.4 kPa. We need to get if your steam tables does not have the actual lambda, you need to get the saturated vapor enthalpy and the saturated liquid enthalpy and get the difference of the two. So in the case of steam at 172, I will just approximate it. Your saturated vapor enthalpy will be 2,700 and your liquid would be 483. That's for the indicated pressure here. Okay, so these are both in kilojoule per kilogram. Then you get the lambda of steam. So you get the difference of the two. So I'm using approximate values, so we will not anymore interpolate. So you have here a 2217 kilojoule per kilogram. So everything is already there in terms of what we need. So we have that, we already have the lambda S. So only missing information here is the S. So if you will have it computed, your feed is, so we'll have here F HF plus S lambda S equal to L HL plus B HV. That's our energy balance equation. Then for the feed, our feed is 5,217. Am I right? And our HF is 240. So you need to substitute it here. Your S and then your lambda S, which we just determined a while ago, 2217. your liquor, 2608.5. So the same with the vapor. 2608.5. Your HL, 500. So this is 500. And you have the vapor 2608.5 and HV, which accounted for the superheat, which is 2664.71. Excuse me, so we can place this as 2665. I'm rounding it up. So you now have the S. So getting the economy would be a case of, so if you will account for the S, kindly solve for the S. My worry is it's now raining here. I can get easily disconnected if this is the case. Your answer for the steam is 3168.89. Okay, this is kilogram per hour. Okay, so if we want the evaporator economy or the steam economy, the final requirement, we need to divide the vapor. Oh, sorry, we know it already. The vapor, which is 2608.5 divided by 3168.89. And this should give you a 0.823. When do you know that your evaporator was designed efficiently or it's economical in terms of the use of energy and in terms of the amount of water it vaporizes per unit amount of energy that is being used? An evaporator is already efficient if its economy is 60% or higher. In our case, for our evaporator, our steam economy is 0.823. So this is already acceptable in terms of the efficiency of the evaporator to vaporize the amount of fluid given the amount of steam that it is using. So this is our answer for this problem. Right? The steam economy is 0.823 in the case of evaporation with boiling point rise. So before I go to the next topic, do you have any question? Which part in the solution would you like to ask for clarification before I go to the next topic? Okay, so I'm assuming that there's none. So I'd like to continue on my slide.
Miss,
Yes.
wait lang, miss. Ang sa may ang CPWMS 1.8 ang maganda constant gina siya, miss.
Constant na siya. Oh, constant na siya. 1.884 is a constant. If it's English, it's 4.18. If your units are in English, the CP that you will use is 4.18. So you have to write it down. If it's SI, that's 1.88. Or if you want to add the other number 4, so much the better. Okay? It's a fixed value when you compute for the superheat of your steam. If it's already a superheated vapor. It's not just saturated vapor, but the superheated vapor.
Thank you, miss.
Okay. So this, do you have any question? More question on sample problem number 4?
Miss, isend mo na siya, miss, ang solution.
Actually, it's already together with the discussion that is recorded. So if you're going to view it on the link, everything is there in the recording.
Sige, thank you, miss.
Okay. Okay, so that's the solution for our sample problem number 4. Can you see my slide now? Can you see the slide?
Wala pa, miss.
Oh,
Wala pa,
sorry.
miss.
Okay, sorry. I was not able to share it. So the one that we solved a while ago is the solution to this sample problem. Now there are other ways, and one of your classmates asked me, is there another way of determining the boiling point rise for a solution wherein the solid content is not known? The answer is yes. So there is this formula that you can utilize in determining the elevation in the boiling point. Now, in this formula, you only need to know the amount of water present in the solution. So XW is the mole fraction of water in the solution. If you are given percentage by mass, all you have to do is convert that to mole percent or mole fraction and plug it in the formula. The lambda V is the latent heat of vaporization of water at atmospheric pressure, which is 40,627.08. What I'm trying to say is it's already a fixed value that you're going to place here together with that of the universal gas constant, which is 8.314. Now, having this formula requires you to input the saturation temperature of pure water. You can know that based on your steam tables. You can get the saturation temperature of pure water on the indicated pressure or temperature of your evaporator. So you can get this from the steam table. The T prime is the only unknown that is left here. So this T prime is already the boiling point of your solution, which is of course expected to be higher than this T here. So if you know the T prime, then you get the difference of the T prime and the T, then that would be your boiling point elevation. That is in cases wherein, again, the solid content of your feed is not known. The problem is silent. What is your solute? What is it? Is it NaOH? Is it NaCl? Is it glucose or something like that? So if the problem is silent, you can approximate the boiling point using this one. But from your phy chem then and in your chem 1, you were given this particular concept of the elevation in the boiling point of dilute solutions. Okay? However, class, the thing is, this is for dilute solution. So meaning, if you really intend to know whether there's a considerable increase in the boiling point of your dilute solution, let's say 9% solid, you may use the molar boiling point constant of the solvent, which is most of the time water. And the value is 0.51 degrees C per mole. And then you are to multiply that with the molality of your solution. The molality of solution from Chem 1 is number of moles of solute per kilogram of water used. You can still determine this using the percentage by mass or the mole percent of your solution. Whether your solution is your feed or whether your solution is your liquor, the thickened liquor. This is in cases wherein you really intend to determine the elevation in the boiling point which you neglected, which you assume to be negligible for a given dilute solution. This is only using the concept of the molar boiling point constant of water and the molality of your solution. In here, you are determining the delta T sub B comparable to the BPE or the BPR of your dilute solution. So if you intend to know the actual boiling point, then you can add this delta T sub B rather, to your saturation temperature. Then you will see, oh, I have neglected something that should have not been neglected because if I'm going to use the principle of phy chem and chemistry 1, there is a considerable increase in my boiling point, which I only assume to be negligible. Okay, but nonetheless, most of the time, the problem is giving NaOH, or the problem is giving you something that is available in your handbook for you to use. Otherwise, then you can use this formula. If you have nothing to use, you don't have the figure, your solid is not on the figure, you don't have a concentration diagram wherein you can get the enthalpies, and you need the delta BE for you to be able to uh, determine the correct enthalpy of your solution, then you can use this formula. Even if it says here for dilute solutions, because there's no other formula to use. So then you are allowed to use this one. Okay? Now that these are the two alternative formulas in determining the boiling point elevation of your solution, which is not dilute. Okay. Now this one is for you tonight to process during your dry lab. Its approach is similar to number 4. It has also BPE because your solid content is 10% to 40%. So this time, you cannot neglect BPE because this one is 40%. You may neglect it here because it's right on the 10%, but your liquor will not fall on the value of less than or equal to 10%. So you cannot neglect boiling point rise. Now, as a guide, however, let me just guide you because I'm sure you are going to ask how you're going to process the problem. The operating pressure of your column is not given in this problem. It's not given. But rather, what is given to you is the condenser pressure, which is under vacuum. Now, if your condenser is connected to your evaporator, then in principal class, they should have the same operating pressure. Otherwise, one will burst and the other one will compress or decompress. These two are connected, your evaporator and your condenser. So if your condenser is in under vacuum at 26 inches mercury, then your evaporator is also under vacuum at this same pressure. So you have to remember that because there are problems that does not give the operating pressure of the evaporator, but rather gives the operating pressure of the condenser. So you can use this one. Okay? So you are given here water at 70 degrees Fahrenheit entering the barometric condenser at a rate of this 100 gallons per minute and lives at this particular temperature. You're given the U and you are to determine here the area. So this is different than the sample problems we have processed because this time it is requiring you the area. This time you will use the Q equal to U A delta T. The Q rather equal to UA delta T formula together with the Q that is determined using the S lambda S. Now you may wonder why give us this information? Water at this rate, you will know. Just you will know. Just critically think. This statement will tell you a very important information that would lead to determining the surface area. So I can give you this, but there is a formula that I have shared with you regarding the amount of water that is being used in the condenser to the amount of vapor that is being processed by that same condenser. So I'm giving you already the clue. That formula will be beneficial together with this statement. That way you can solve for the required information here in the problem. You will still process this in groups. Only one solution for the group. The solution should be complete. It should have given, required, and solution. And it should be submitted within the time for the allotted for your dry lab. This is to be submitted then tonight. What will happen on Thursday is this. You will have a quiz on the dry lab time. And that is from 7 to 8:30. So make sure that you have eaten something because from 5:30 to 7, I will discuss multiple effect evaporation. Plus, I will not anymore use my Jamboard because it really takes time. So what I'm going to do, since the process of multiple effect evaporation plus sometimes uses like 5 pages of paper and you're not yet done. So what I'm going to do, I'm going to share to you a ready-made solution that is already outlined so that we can only understand the process of having to go through the steps when in case of the multiple effect evaporation. Anyway, I think the first four problems in which I have used the board on how to really go through finding the information that you need to find is already enough. So for the multiple effect evaporation, I may use the Jamboard, but I will rely entirely on the ready-made solution for us to be able to finish one problem in 1 hour and a half. Otherwise, we will incur probably 3 hours and we're not yet done if like actual, just like what I did tonight, we're in I give the information, we get the information from the steam tables, and so on and so forth. So it will really take time. Okay? So I will post an announcement in Canvas. That way you won't forget. You will have your quiz on the dry lab schedule on Thursday. That would be your first quiz for midterm. The coverage would be single effect evaporation without BPE and with BPE. No concept will be included in the quiz. I will only have problems on the quiz. Give only problems on the quiz. On the 5:30 to 7, you will have the usual lecture because I think a simple recorded lecture will not be enough. It would be something not any more interactive unlike the previous. No? Pwede lang ka-substitution sa formula, okay na ta. In the case of multiple effect evaporation, there's a trial and error part wherein just like in your C++, if you're doing a program that is uh, performing a loop, that's what you're going to do with multiple effect evaporation. It's a procedure that has a loop. So you will return to a certain part of the procedure if one part does not conform to the condition that is stated in the steps. Okay? The last part actually is multiple effect, and it's normally the most tedious part of topic of evaporation. And that particular problem is, I think, number 6. This is sample problem number 6. And you have number 7 and number 8, the last, which will be, of course, processed by you and submitted on the schedule of the exam. That has been my practice because these are long problems and they will need more time to process. So you have 2 weeks to process the 2 problems, the last 2 problems here, considering multiple effect evaporation. You have any question, class? My time now is 6:46, so you can have your early dinner. That way you can
Yes.
do your problem. Yes.
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 Parang question kung is about sa city, tas skim na lang sa English, miss.
Uh,
Kaya nakita ko, miss, 0.45, miss, or 4.80.
0 point.
45. Nakita ko, miss.
Okay. Tsakto na siya iha. 0.48, 4.8 hambal ko. 0.45. That's right. So,
Yes.
please, correct na siya. Correct na siya. So, it's 0.45 if it's English. Actually, you can get it when you convert the 1.88 to English. Anyway, it's a constant. So, thank you for bringing that up. If it's English, that's 0.45. I stand corrected. Ara, so ulo ko ang
Okay, miss. Thank you,
4.18.
miss.
Okay.
Miss, good evening.
Yes.
Miss, regarding bala sa last activity, nga question number 2 kag number 3, kasi pwede kami send solutions, miss, kaya hindi kami sure sang lasang amon answers, para ma-review manamon, if okay lang, miss.
I will actually provide you with all solutions sa even sa mga prelim pa. Kaya I have also the solutions of those. Just the thing is, kaya wala pa ko katapos check, so hindi ko mahatagan kaya wala pa ko katapos check. When I'm done, I will really provide you with the solution of everything. So you can also have it filed for future reference. Okay? And by the way,
Thank you, miss.
okay, your teachers, were given by admin. It was announced only yesterday due to the meetings that we have to attend. So before this class, actually, we have a meeting, and in a week we have at least 2 meetings to attend to at least. So it could be more than that. The grade submission for us was extended until October 19. Considering the hardest part of this online class, which is on the preparation of the online module. So amo gina siyang take time, hindi gid mo tayo masasaang pag-check. But rest assured that by the time that it's already the deadline, you will have your grades, you will have your scores, and you will have the solution to the problems that were given you. And you cannot validate if your scores were correct if you will not be provided with the solution of such problems. Hi? Remind me. Anyway, practice ko man gina-post ko. Ang sa inyo lang actually ka ang sa review class ko ang wala ko gid ma-post ang solution kay kalagwig sa solution pa. But in my DE and my other classes, nag-post ko solution sa Canvas para ma-check sa estudyante. Hi?
Yes. Hello, Miss.
Yes.
Miss, may clarification lang ko tani, Miss, for problem 5, bala misaw. Kay, ang 100 gallon per minute, Miss, amo na siyang feed, Miss, sa condenser, Miss. Amo na siyang feed rate, Miss.
What do you think?
Oo, Miss.
So it depends on you. So you have the three among you to discuss that. Is this the water that is being processed by my condenser? Meaning, is this the vapor that is to be condensed? Or is this the rate of the cooling water fed to the condenser? I think the English there, Zara, will tell you what it is. I will not tell you so that you will think.
Okay, Miss. Miss, nang last na lang gali, Miss. Ang sa to bala Miss sa ginsolve, taman Miss sa number 1, nga ginsolve man nga do ka similar problem sa number 2, Miss. Mamangkot ako bala Miss, ang Q nga ang sa Q is equals to S lambda bala Miss nga i-input sa Q is equals to A nga delta T, U, A delta T. Dapat naka-watt gina siya, Miss, ang unit.
Okay. Kung ang imo nga U, syempre kung ang imo U iha, may watt per square meter per hour na siya bala, or watt per square meter per Kelvin for your U, then dapat naka-watt ang Q mo para mag-agree mo units. Hindi pwede nga mga kilojoules kada kay ang watt taya joule per second. So pati time mo nga hour, i-convert mo man sa seconds. You have to make your units agree. Most U is in watt. So convert mo gid na siya. Ang imo nga kilojoule per hour, for example, to joule per second. Did I answer your question?
Miss. Thank you, Miss.
May na-remember lang kung may nag-ask nga classmate ninyo, Miss, paano gali, Miss, na ano to nga number ginatag ko? Ang CP, Miss, kay wala kami kabalo sang CP. Wala kami, Miss, matagaan sang CP nga gamito namon. Actually, since your solution is dilute, okay na nga CP sang water. But if you want a more accurate answer, wherein you made use of the CP of your feed or of your water in reference to the solid content, then the sample problem that I'm going to give you for multiple effect evaporation will answer that. Pero sa amo lang to anay nga problem nga gin-answeran nyo sang last week, CP of water will do because dilute siya. Behavior niya is comparable to that of water. Pero kung hindi ka mo gusto nga magamit sang CP, sang water, kag ang correct na CP, based on the CP of the feed and the solid contents of the feed and the mother liquor, that will be taught to you in multiple effect evaporation, which tani, subong nga gabi, kala ko malabot, wala git madala. Okay? Dito ko na lang i-discuss kay masulit ng mangyapon kung i-discuss ko na kay gamiton ng tugyapon ang principle dito. Okay, kay may isa ka mga classmate nga nag-ask about that. So, amo na, in-share ko na lang sa inyo. Probably you will wonder nga, tsakto to ayhan. So, tsakto na siya. CP lang isang tubig ang ganito. Pwede na. Kay behavior, comparable to that of water. Okay? Some more questions. I have 6 minutes left.